आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hi there, today our question is prove that the equation of the normal to the curve x to the power 2 upon 3 plus y to the power 2 upon 3 is equals to a to the power 2 upon 3 is y cos theta minus x sin theta is equals to a cos 2 theta, right? Where theta is the angle which the normal makes with the axis of x. So we have to find out the equation of normal to this curve, and then we can just prove that this will be our equation of normal. So we'll write the equation of the curve first. Equation of curve is x to the power 2 upon 3 plus y to the power 2 upon 3 is equals to a to the power 2 upon 3, right? So this is what our equation of curve, and we know that if we differentiate this equation with respect to x, dy by dx, then we can get dy by dx, right? And dy by dx is what? Our tangent slope, right? So we will differentiate this equation with respect to x, and we will get, this will become 2 upon 3 x to the power 2 upon 3 minus 1. We know that power is decreased by one number, right? And similarly here we will have 2 upon 3 y to the power 2 upon 3 minus 1 is equals to 0. Differentiation of a is 0, and we know that differentiation of y will be dy by dx. So we will write a dy by dx also with the 2 by 3 y to the power 2 by 3 minus 1 term. So here we will get 2 by 3 x to the power minus 1 by 3 plus 2 upon 3 y to the power minus 1 by 3 is equal to 0, and we have a dy by dx term also. So we will write it with y term. So dy by dx, right? Similarly in the second part also we will write dy by dx. What are equation after finding the differentiation? So from here we can say 2 by 3 will be cancelled out, and we will left with x to the power minus 1 by 3 plus y to the power minus 1 by 3 dy by dx is equals to 0. And from here our slope of tangent will be, that is dy by dx will be minus of x upon minus 1 by 3, right, upon y to the power minus 1 by 3, because y term is in multiplication with the dy by dx term, right? So now we can write it as y to the power 1 by 3 upon x to the power 1 by 3. As we know that x inverse can be written as, a inverse can be written as 1 upon a, right? So we have just used that identity here to find out the slope of tangent, right? And we know that the slope of tangent into slope of normal gives us minus 1. So we'll write here the formula m into t, m of t and m of n is equals to minus 1, right? And we have to find out the equation of slope. So we can slope of normal. So we can find out the slope of normal using this formula, and we will get mn is equals to minus 1 upon minus t, mt. So here our slope of tangent is, slope of normal will become x to the power 1 by 3 upon y to the power 1 by 3 after reciprocaling the tangent slope, right? So this is what our slope. Now we know that the slope is equals to tan theta also, right? So we can write tan theta is equals to m of n, slope of normal, right? And we have we know that tan theta is equal to sin theta upon cos theta, right? Sin theta upon cos theta, and also tan theta is given as x to the power 1 by 3 upon y to the power 1 by 3. So we will equate the both equations because they are same. So we will get sin theta upon cos theta is equals to x to the power 1 by 3 upon y to the power 1 by 3, right? Now we will shift y to the power 1 by 3 on the left hand side, on the right hand side, and we'll get sin upon x1 by 3 and cos upon y1 by 3. Let's say that this is equals to our some constant k, right? So then after this will become, let's say that x upon x, we are just reciprocaling it and remove this constant for now. X to the power 1 by 3 upon sin theta is equals to y to the power 1 by 3 upon cos theta is equals to some constant k, right? Now we can derive x in terms of a constant k. So we will write here that x to the power 1 by 3 is equals to k sin theta, right? Similarly for y, we will have y to the power 1 by 3 is equals to k cos theta, right? Now we can say that 1 by 3 will shift to the right hand side and will become cube for both terms k and sin theta. So we will get x is equals to k cube sin theta, sin cube theta, and y will become k cube cos cube theta, right? So this is what are values of x and y, right? So these are some general points on the normal, right? And we know that normal is passing through this curve, right? The given curve x to the power 2 by 3 plus y to the power 2 by 3 is equals to a to the power 2 by 3, right? So we know that the normal and curves are intersecting each other at some point x. So we can say that this xy will also satisfy the equation of curve, because the normal and curve are intersecting with each other at some point. So we'll write here xy satisfies the equation of curve. Now we will put these points into the equation of curve, and this will give us x to the power 2 by 3 plus y to the power 2 by 3 is equals to a to the power 2 by 3. This is the initial equation of curve, right? Now we are putting the points, and it will give us k cube sine cube theta whole power 2 by 3 plus k cube cos cube theta whole power 2 by 3 is equals to a to the power 2 by 3, right? And 3 into 2 by 3 will become 2 only, right? We can say that 3 into 2 by 3 is 2. So we'll write k square sine square theta plus k square cos square theta is equals to a to the power 2b, right? Now take k square common, right? And then we will left with sine square plus cos, and we know that sine square plus cos square is equals to 1. So we are taking k square common, and we will left with this equation, right? Now sine square plus cos square will become 1, and we will left with k square only. So we can say that k square will be equals to a to the power 2 by 3, and from this equation we can say that k is equals to a to the power 1 upon 3, right? We are taking under root on both sides, and we will get k is equals to a to the power 1 by 3. Now we will put this value of constant k into our general points x and y, right? So general points was x is equals to k cube sine cube theta, right? So we will say this is our general point, x is equals to k cube sine theta and y is equals to k cube cos cube theta. So we will put the value of k into these points, and we will get k cube sine cube theta. This will become a to the power 1 by 3 whole power 3 sine cube theta, right? And 1 by 3 and 3 will be cancelled out, and we left with 1 power only of a. So we will get a sine cube theta. Similarly for y we will a to the power 1 by 3 to the power, whole power 3 so cos cube theta. This is a cos cube theta, right? So this is what our value of x and y, right? Now we have the equation. Now we can find out the equation of normal, because we have the points and we have find out our slope also, right? So we will write here the equation of normal will be the points are given as x and y, and the slope is x to the power 1 by 3 and y to the power 1 by 3, right? This is what are slope and points. So using slope point form, we can write here that y minus y1 is equals to m x minus x1, right? And y1 is a cos cube theta, so we'll write y minus a cos cube theta is equals to m is what, x to the power 1 by y to the power 1 by 3, right? And x minus x1, so x is x and x1 is a sine cube theta, so we'll write x minus a sine cube theta, right? Now we'll multiply. We can say that x to the power 1 by 3 upon y to the power 1 by 3 is our slope. We can that can be written as tan theta, right? So we'll write here tan theta into x minus a sine cube theta, right? And tan theta can also be written as sine theta upon cos theta. So we'll write sine theta upon cos theta x minus a sine cube theta, right? And all other terms will be remain same. So we can say that we multiply cos theta on the left with y and a cos cube theta, then this will become y cos theta minus a cos to the power 4 theta, right? And on the right hand side we will have x sine theta minus a sine to the power 4 theta, right? Now we will shift all the terms onto the left hand side, or we can say we are shifting all the terms on the right hand side. We will get y cos theta minus a to the power minus x sine theta minus a to the power cos 4 theta, and this minus a sine to the power 4 theta will become plus when we shift it to the left hand side, and we are taking a common from that terms, cos to the power 4 theta minus sine to the power 4 theta, right? Now we'll use here the identity a square minus b square, that says a square minus b square can be written as a minus b into a plus b, right? So here our a square will be cos square to the power square, right? Square of cos square. So we can write this as y cos theta minus x sine theta minus a cos square square, right? cos square square and sin square square. So we are taking square now, right? So this is what our a square minus b square. Now we can use the identity in this equation and we will get cos square theta minus sin square theta into cos square theta plus sin square theta according to the above identity, right? Cos square theta plus sin square theta, and the other term will remain as it is equal to 0. Put a within brackets y cos theta minus x sin theta minus a, right? So we know that cos square plus sin square is 1, right? And cos square minus sin square is cos 2 theta. So we will get y cos theta minus sin theta minus square theta minus sin square theta is equal to 0. So now we will write y cos theta minus x sin theta minus a into cos 2 theta is equal to 0, right? Because we know that cos square theta minus sin square theta is equals to cos 2 theta. So this is what our equation of normal that we have to prove, that y cos theta minus x sin theta minus a cos 2 theta is equals to 0, right? That is what our final answer, right? Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।